How to use a cloud of cultural heritage knowledge graphs in digital humanities research, and why this is useful in practice. This invited talk introduces a new idea and in-use system for publishing and using cultural content on the semantic web. SampoSampo, connecting everything to everything else, arguably a step towards a web of wisdom. I am Eero Hyönen from the Aalto University and University of Helsinki, Finland, and Geneva Graduate School, Switzerland. My colleague Petri Leskinen is also present in the audience. Please stand up, Petri. Thanks to other SampoSampo team members, Anna-Stiina Ahola, Heikki Rantala, and Jouni Tuominen for collaborations, and tens of other people and organizations who have been developing and funding the Sampo systems underlying our work on SampoSampo. I will first present a vision of a web of wisdom, and then consider how to create it, based on lessons learned in Finland. After this, the SampoSampo system and its use cases are presented. Let us first define the needed components for a web of wisdom: artificial intelligence, semantic web, and digital humanities. In digital humanities, methods of computer science are developed for solving research problems in humanities and social sciences. The idea is also to study digitalization as a phenomenon and to shape digital technology to serve human values, rights, and well-being, an area called digital humanism. Semantic web research aims at developing an intelligent web by combining methods of computer science, AI, and web technologies and standards. What if we combine research in digital humanities and semantic web? What is the added value, the sum of the two approaches? Our semantic computing research group at the Aalto University and University of Helsinki has studied this problem for 25 years by now. The editors of Journal of Web Semantics invited me to write a visionary article for the special issue on how the semantic web is developing in the future. In my article, I applied the data, information, knowledge, wisdom hierarchy of data science for this. The idea is that new value is added as raw data on the bottom is transformed into information, know what, to knowledge, know how, and finally to wisdom, know why. At the same time, traditional web is transformed on the left into the semantic web on the knowledge layer, and finally into something that can be called web of wisdom on the wisdom level. The semantic web is already rooted in AI research, but on the web of wisdom, explainable artificial intelligence is needed for answering the why question, not only for solving problems. Based on this view, the sum of digital humanities and semantic web can perhaps be set as the web of wisdom. But how can we create a web of wisdom? Here are some lessons learned in Finland. A web of wisdom is based on the semantic web, that is based on linked data. The Renaissance genius Leonardo da Vinci once said, "Learn to see. Understand that everything is connected to everything else." This seems to indicate that probably he was the first scholar to come up with the idea of linked data, along with his other inventions, as early as in the 15th century. In my mind, an essential element for a web of wisdom is a domain-specific national semantic web content infrastructure, based on the domain-agnostic semantic web infrastructure standards and best practices developed internationally by the World Wide Web Consortium, as well as data models and software tools. For building applications, shared ontologies served by centralized ontology servers are needed, as well as linked data services serving datasets for studying them and for reuse. As the web is developing quickly, building and maintaining a human infrastructure for using the infra is needed too. This work is being carried out at the moment in Finland as part of the FinClaria Daria Fi Research Infrastructure Initiative. Albert Einstein has said, "Intellectuals solve problems, but geniuses prevent them." This wisdom applies well to infrastructure building. Using a shared, standardized infrastructure when cataloging data in memory organizations would make it much more cost-efficient to break data silos later and to develop applications. The SampoSampo system to be described in this talk is based on a set of Sampo systems available on the web that in turn are based on the so-called Sampo model illustrated in this image. The model has evolved gradually over a period of more than 20 years. It is based on a collaborative shared data and ontology infrastructure on the left in the image that is used for aggregating, harmonizing and enriching linked data from multiple cultural heritage organizations and data sources. The data is published as knowledge graphs in the data service and Sparkle endpoint. In our case, the Linked Data Finland platform is used. The endpoint is used via a Sparkle interface in the applications and tools layer illustrated on the right. The data can be used directly in digital humanities research by scripting on the other hand, and through applications such as Sampo portals on the other. Since 2004, we have published some 25 lodge services and semantic portals on the web based on the Sampo model. Culture Sampo publishes museum collections enriched by over 20 other types of data, including the narrative of the national epic Kalevala. Book Sampo, with its 1.6 million annual users, is joint work with the public libraries of Finland, with a focus on Finnish fiction literature. Biography Sampo is based on the biographies of the National Biography by the Finnish Literature Society. Name Sampo contains some 2 million place names in Finland for toponomastic research. War Sampo is based on data from the National Archives, Defense Forces and other organizations. It is a popular web service that has been visited by some 1.2 million distinct users. Letter Sampo is joint work with the Oxford University, Haynes Institute and Berlin-Brandenburg Academy of Sciences on epistolary data research, and Sampo publishes medieval manuscript data from the Schoenberg Institute in Pennsylvania, Bodleian Library in Oxford, IRHD Institute in Paris. Find Sampo and Coin Sampo are about archaeological finds and citizen science. Parliament Sampo publishes all million speeches of the Parliament of Finland, and Law Sampo, Finnish legislation provided by the Ministry of Justice. Opera Sampo is joint work with the Sibelius Academy about historical opera performances. Last year, the massive Letter Sampo Finland was released, and this year SampoSampo connecting different Sampos together, and the League of Nations Sampo with the Geneva Graduate Institute in Switzerland, based on the data from the United Nations Library and Archives. We have learned that linked data technology works like a Swiss knife to different kinds of datasets. The name Sampo comes from the Finnish epic Kalevala, where Sampo is a mythical artifact that gives its owner riches and good fortune. It is a metaphor of amazing ancient technology. Kalevala has been a central source of inspiration for Finnish culture and also arguably for J.R.R. Tolkien in his novel The Lord of the Rings. Let us have a look at the typical Sampo system and project. Letter Sampo, historical letters on the semantic web. This system is based on data about international correspondences between scholars in early modern Europe and beyond, the so-called Republic of Letters. Letter data was available in the early modern letters online system aggregated from various European archives by the University of Oxford, but not as fair linked data for semantic search, browsing, data analysis, and intelligent application development.
This video introduces the Letter Sampo project at the Aalto University and Helsinki Center for Digital Humanities Helsinki. We are developing a framework and a demonstrator for publishing and analyzing historical epistolary data in digital humanities based on semantic web technologies. This new project in Finland was inspired by our earlier collaborations with the Pan-European EU Cost Action Reassembling the Republic of Letters and the University of Oxford, related to historical letters sent from the 16th to 19th century in Europe and beyond. Letters are always sent from a place to another and are therefore scattered in different archives in different countries, written in different languages. Harmonizing the metadata from separate data silos and aggregating the data into a semantically interoperable global service for digital humanities analyses makes a nice use case for the Sampo model and Sampo UI framework. developed at the Semantic Computing Research Group. The SampoSampo model includes a collaborative business model for collaborative data publishing in a shared linked data service, the idea of accessing the data from multiple perspectives, the idea of integrating the service seamlessly with data analytic tools for research, and finally, a model for addressing research questions in 2 steps, where faceted search is first used for filtering out data of interest, and data analysis and visualizations are then applied to it. We next illustrate this idea by showing examples on analyzing letter data by using the SampoSampo demonstrator. This is the main entry page for the SampoSampo user interface. The application consists of 3 perspectives to the underlying data: the actors, the letters, and the places. The underlying dataset in this example contains information about a total of 34,000 actors. By actor we mean an individual person or group of people like universities or religious organizations. In the faceted search we can filter or search specific actors by their name, gender, or times of birth or death, or groups of actors for prosopographical research. For example, we can search for the mathematician Gottfried Wilhelm Leibniz. On the result page we will see him among the other matches. The result table shows his years of birth and death, and the amount of the letters involved, based on the underlying metadata. On the person landing page we will have even more information about him and his correspondences. In addition to showing his basic biographical information, the page contains fields for his alternative names and vocations. There is a list of all the other actors with whom he has been in contact. It should be emphasized that any visualization or data analysis in a system like SampoSampo is an analysis of the underlying dataset, not of the real world. Any conclusions drawn from the analysis need source criticism and understanding the limitations of the data. For example, in this example there are 149 letters of Leibniz and the data misses lots of letters. Leibniz was a very active writer with some 15,000 letters and 1,100 correspondence. So in this case only 1% of those are available in the demonstrational dataset. In spite of this, analyzing an incomplete letter collection by distant reading can give novel insights to the researcher and collection manager, and suggest topics of interest for further close reading. The first person on the list is Christian Huygens, with whom he has sent 70 letters, as far as the data can tell us in this case. There are also detailed lists of all letters sent or received by him. The last result on this page shows a list of places he has been active and based on data about sending or receiving letters. The next tab, Network of Letters, shows a visualization of actors' egocentric network. The link width between 2 actors indicates the amount of mutual correspondence. The wider the link, the more letters has been sent between the 2 actors. We can for instance spot that Leibniz sent 39 letters to Christian Huygens, while Henry Oldenburg sent more than 200 letters to Huygens. Again, this analysis is based on data about only a fraction of Leibniz known letters. The next tab illustrates the number of letters on a timeline, where we can observe that the data is based on letters from 2 periods, the first one in the 1670s, and the second in the 1690s. This could indicate the collection manager that letters in between may be missing. The letter perspective page has a similar faceted search application as the actor page. Here we can browse and filter the data of 162,000 letters by their sender, receiver, date, language, subject, or data source. The second tab on the letter page visualizes the letter routes on a map application. Currently we are viewing the routes of letters sent from Paris. The third tab on the letter page demonstrates the amount of correspondences on a timeline. From this curve can be seen that the data is distributed from 16th to 19th century, with the majority of letters in the 17th century. In addition to the ready-to-use data views in SampoSampo, the underlying Sparkle endpoint can be used easily for further data analyses using, for example, Python scripting in Google Columns. This data table shows the most active mathematicians in the data set, filtered out from the data. The left column shows the actors ranked by the number of letters sent. In the middle column ranking is based by the number of received letters, and on the right by the total amount of letters. The blue text color indicates that the actor has written more letters than what he has received. This is a visualization of the top writers between the years 1620 and 1770, and the ranking of the author is depicted on the y-axis, so that the highest ranking actor appears on the top of the diagram. Based on the underlying collection data, in the 1620s and 1630s Marin Mersenne was at the highest rank. Christian Huygens was among the top writers during the years 1650 to 1690s. Isaac Newton has been an active writer in the late 17th and early 18th century. And finally we have Leonard Euler, who's been the top writer during 4 decades from 1730s to 1760s. Thank you all for watching this video. More information about the Letter Sampo project is available at the web page of the Semantic Computing Research Group.
For user interfaces, we created a tool called Sampo UI. Based on Sampo model, Sampo UI introduces a standard user interface model and logic for using knowledge graphs based on their key concepts: classes, instances, and properties. The model is easy to learn by end users and easy to use by developers. Sampo UI can be plugged on top of virtually any Sparkle endpoint by adapting Sparkle queries to match the underlying data model and by modifying ready-to-use user interface components declaratively using JSON files. The landing page of the Sampo portal contains a series of windows that allow one to search, browse, and analyze the underlying knowledge graph from different perspectives based on the classes of the knowledge graph. A perspective for a class contains a faceted search engine whose facets are based on the properties of the class. By making selections on the facets, the corresponding subset of individuals of the class are retrieved as the search result, and hit counts on the facet categories are updated to guide search. The result set can then be analyzed on different tabs, for example, on a map or timeline or using charts and graphs. At any point, an individual can be chosen for a closer look at its instance page that provides comprehensive linked data about the individual. Here it is possible to analyze, visualize data about the individual by using separate tabs too. Based on the same interface model, Sampo portals look the same and share similar functionalities. We have been happy with it and have not modified it much, even though also this would be possible. In recent years, Sampo UI has been used by many foreign universities. For example, researchers from the University of Latvia presented the Nobel Prize Sampo at the Vienna Semantics Conference in 2025. It's based on the Sparkle data service of the Nobel Foundation in Sweden. The Geneva Graduate Institute in Switzerland has implemented a Sampo based on Parliament Sampo for the minutes of the General Assembly of the League of Nations. Based on systems like the Letter Sampo, we have now created a new kind of meta Sampo, or mother of other Sampos, SampoSampo, connecting everything to everything else. In Finnish, kaikki kaikkeen kietoutuvi, using the special Torquay poetic foot of the Kalevala epic. SampoSampo is based on a cloud of linked open data knowledge graphs underlying the Sampo series of systems in different cultural heritage fields. The idea of SampoSampo is to develop a new data service that links Sampo entities, such as people and places, to each other, and enriches the data with links to external data services in the international linked open data cloud. The linking service is somewhat similar to the international viaf.org system, which links authority data from national libraries in different countries, including key external data services such as Wikidata and the ontologies of the Chetty Foundation in California. SampoSampo's new innovation is the smart SampoSampo portal, developed based on the data linking service, in accordance with the Sampo model. It links information on approximately 100,000 historical people, 55,000 organizations, and 27,000 places. This image illustrates linkedness of different sampons and external knowledge graphs, represented as blue nodes in the graph in terms of shared people entities. Shared people are represented by arcs between the knowledge graphs with a number indicating the number of shared entities. For example, of the 22,000 people in Biography Sampo, 4,900 people have an entry and more data available in Academy Sampo. It is, these people have been affiliated with the Finnish University between 1640 and 1899. SampoSampo aims at 4 practical use cases. Firstly, SampoSampo can be used to enrich data when creating new samples. Secondly, SampoSampo search and other functionalities can now be extended globally across different samples. Thirdly, the system allows for quality checking of interlinked datasets by comparing data available from different primary sources. Fourthly, SampoSampo offers the opportunity to discover new interesting connections between entities in the data and explanations for these in natural language. I will next explain these use cases in more detail. SampoSampo linking service can be used for creating data links in new applications and datasets in the same manner as VIAF.org, the virtual international authority file linking service between national libraries. The idea of entity linking has also been applied in the same as links that connect entities in the knowledge graphs of the linked Open Data Cloud and in the linked vocabularies project. SampoSampo data is available at the Linkdata Finland platform, where it can be accessed and utilized by using a Sparkle endpoint. The data can be downloaded from Zenodo. As an example, we have used SampoSampo in enriching the data of the Letter Sampo Finland system that publishes data about 1.3 million letters from the 19th century Grand Duchy of Finland. The idea of global search, browsing, data analysis across sampos based on globally enriched contents is demonstrated by the SampoSampo portal. This means that several samples can be searched at the same time, enriched descriptions of the search results can be provided using multiple data sources with provenance, and the data analysis can be extended from individual knowledge graphs over the global cloud of data. SampoSampo landing page contains application perspectives for people, organizations, places, and explained relations between entities, and a listing of primary data sources. There are also shortcut links to example searches and data analysis. In this screenshot, the user has opened the people perspective. From the facets on the left, she has selected gender is female, and the result, some 20,000 women out of 100,000 people, is shown on the table tab on the right. The result includes, for example, Helen Scherfbeck, the painter. By clicking on Helen Scherfbeck, her aggregated enriched metadata and links can be studied on different tabs. The result set can be visualized and studied in different ways on the tabs. Here the lifelines of the women from their place of birth to place of death are shown as color-coded interactive arcs. By comparing the data about entities in different datasets, SampoSampo can also be used for checking the quality of the primary sources. It is possible to find obvious errors. For example, according to Academy Sampo, Mr. Carl Henrik von Knorring lived between 1793 and 1863, but the National Bibliography database Kanto of the National Library gives the birth year 1973, which is clearly on typo. We have also found lots of contradictions, such as two close birth years of Mr. Gustav Walfrid Vasenius. Also possible duplicates in the data can be found. It is then up to the data owners to check whether their own data or that of their fellow organization is wrong. For example, This screenshot of the instance page of Bishop Mikael Agricola, known as the father of Finnish language, shows disagreements in red between datasets regarding the times of birth and death, as well as the place of death. The data sources are indicated as provenience data links for further analysis. SampoSampo also extends the idea of semantic search to searching inconsistencies in the data. By using the facet inconsistency type, it is possible to search inconsistencies systematically. For example, we found 42 issues with the gender of the people. By using the data source facet, it is possible to find by 2 clicks all potential inconsistencies in a particular dataset for corrections in the primary data. For example, the public libraries of Finland use this possibility to correct their data in BookSampo. In the first version of SampoSampo, thousands of inconsistency issues were found as listed in this graph, visualizing their distribution in the inconsistency type facet of the people perspective. In addition to people, also inconsistencies of places based on their coordinates can be analyzed in SampoSampo. The idea here is to compute a kind of average sampled coordinate point for the location using the line basis, and then mark those who differ from it more than a criterion as inconsistent. This image shows different coordinates used for Canada in different datasets. The final use case of SampoSampo is knowledge discovery of new or even serendipitous connections between entities with natural language explanations. 2 methods have been tested here: relational search by exploring link chains between entities and using generative AI and large language models for reasoning relations. Relations can be searched not only between individuals but also groups of entities. For example, an explained relation between the group's painters and the places in Italy is Elin Danielsson Campocci got the Florence City Award in 1899. Our approach was to design a data model and the relation class of explained relations and then generate instances of relations in different ways into a knowledge graph. The relation instances can then be searched and studied as usual in Sampo portals. The first version of SampoSampo contains over 190,000 relations generated in this way as listed in this slide. Recently, a subject of intensive research has been the combination of large language models and knowledge graphs into so-called neuro-symbolic AI. Here, language models are used to solve limitations of knowledge graphs, such as challenges in knowledge acquisition. On the other hand, knowledge graphs are used as a remedy for the problems of language models, such as hallucinations. In SampoSampo, large language models have been used to automatically build knowledge graphs and in knowledge discovery of new relations with explanations. The underlying knowledge graph has been used to create prompts for large language models using the retrieval augmented generation methodology with less hallucinations. For example, we have used LLMs for extracting for SampoSampo new explained relations between people and places by using the text or biographies underlying the biography Sampo system. The idea here was to study how LLMs can be used to enhance relational search and how to reduce hallucinations by focusing on a set of predefined relation types of interest and by using the biographies as a context. In the biography Sampo's knowledge graph included in SampoSampo, there were already lots of explained relations available that had been extracted from a semi-formal biographical synopsis of the protagonists, but the more detailed free-text biographical narratives had not been utilized. For example, the semi-formal lifespan expression in the synopsis of the actress Ida Alberg could be transformed into her birth and death events. The biographic texts had already been run through a named entity linking process where people, places and organizations mentioned in the biographies had been automatically recognized and linked to the entities within the biography Sampo knowledge graph. In our case study, The mentions of places served as contextualized candidates for generating new person-place relations for the protagonists of the biography. GPT-5 Mini was used with prompts based on the named place entities in the biography. The model was also asked to list the internet sources used and to provide a brief explanation of what information the model claims to have been obtained from each source. The results were requested in JSON form that was then transformed into linked RDF data. Here is an example of a relation about receiving a film award related to the Sodankylä City Festival in Finland. The relation could be extracted based on 4 different internet sources with statements for its justification. This relation was not there in the original biography Sampo knowledge graph. A sample of the results were evaluated. It was checked manually whether the relation explanation matched the relation and whether the statements based on the internet sources were correct. Interestingly, LLMs found new relation types that were not in the original knowledge graph and that were not anticipated in the prompts. This small case study indicated that LLMs enhance relational data generation. Including knowledge graph data to focus relational search improves data quality. All relation descriptions found were correct. Hallucinations were present for the statements related to sources, of whom 90% were fully correct and 8 partially correct. Visibility of provenance information is important for users to assess reliability. The LLM results indicated a clear potential for serendipitous knowledge discovery. It is finding unexpected patterns of knowledge in the data. This screenshot illustrates how faceted search can be used for knowledge discovery between people and places. On the left, the facets for persons, places, relation types, and data sources can be seen. 14 relations of 4 different types with explanations are found on the right for the painter Elian Danielson Cambocci, 7 from Art Sampo and 7 from Biography Sampo. The relations include the career or studies of Eliel Danielson Cambocci are related to an event in Paris. She studied at the Académie Colaros in Paris 1883-1885. And Danielson Cambocci has created the artwork on Lake Massa-Chioccioli, which depicts a location in Italy. In this screenshot, people-place relations are used to enrich a person's instance page on the Map tab. Here, 145 places related to Marshal Mannerheim in different ways are shown. By clicking on the marker in Denmark, related relations are found, such as getting the Order of Elephant decoration, the highest honorary medal of Denmark. Summary. This timeline summarizes our work on building and applying the national semantic web infrastructure in Finland in relation to major international developments and phases. Here, ontologies, the silver palette of the semantic web, were first in focus. After that, ideas of linked data publishing took off, and during the last 10 years, ontologies and linked data have been studied together as knowledge graphs in various domain-specific application settings. We are entering the time of AI and neuro-symbolic intelligent systems. The work in Finland has followed the same pattern with major projects such as FinOnto for ontologies, Linked Data Finland from Linked Open Data, and various Sampo projects on knowledge graphs. Also, first steps towards knowledge discovery and AI have been taken. All work has been based on standards and best practices of W3C and others illustrated at the bottom. During these years, we have learned that it makes sense to develop shared linked open data infrastructure step by step together with all stakeholders involved. For cost-efficient work, it is important to reuse the shared LOD infra for applications. LOD technology is very resilient for different domains and languages and can be reused in different kinds of applications. And finally, using large language models with knowledge graphs opens a promising way to neuro-symbolic AI, where the complementary strengths of sub-symbolic and symbolic AI are harnessed. Our work is today part of the National Finklaria Darjafi Research Infrastructure Initiative. In Douglas Adams' novel Hitchhiker's Guide to the Galaxy, artificial intelligence was asked about the purpose of life, the universe, and everything. The result of the calculation for 7.5 million years was 42. The answer may be correct, but it would be nice to know why 42. Especially in digital humanities, AI needs not only problem-solving skills, but also the wisdom to answer why questions. This is being studied in the research field of explainable AI. With such AI, we can take the next steps forward towards a web of wisdom. More information, some 600 publications, and links to different samples and infrastructure services can be found on the home pages of the Semantic Computing Research Group.